Hello and welcome. I am Professor Adesh Kumar Shrivastava, Associate Professor, School of Management, BBD University, Lucknow. Today, I'll be discussing schema and sub-schema in DBMS. Schema. Database changes over time when information is inserted or deleted. The collection of information is stored in the database at a particular moment is called an instance of the database. The overall design of the database is called the database schema. This is a diagram, a schema diagram as shown above. It displays only names of record types, that is entities, and names of data items, that is attributes, and does not show the relationship among the various files. The schema will remain the same while the values filled in to it change from time to time. When the schema framework is filled in with data item values, it is referred as an instance of the schema. The data in the database at a particular moment of time is called a database state or snapshot, which is also called the current set of occurrences or instances in the database. In other words, the description of a database is called the database schema, which is specified during database design and is not expected to change frequently. A displayed schema is called a schema diagram. This is the schema diagram which displays only some aspect of a schema, such as the name of record types and data items, and some of constraints. Other aspects are not specified in the schema diagram. It does not specify the data type of each data item and the relationships among the various files. So we have seen that schema does not specify the relationship among the various files. Now we will see the schema in detail. A database schema is the skeleton structure that represents the logical view of the entire database. It defines how the data is organized and how the relations among them are associated. It formulates all the constraints that are to be applied on the data. A database defines its entities and the relationship among them. It contains a descriptive detail of the database which can be depicted by means of a schema diagram. It is the database designers who design the schema to help programmers understand the database and make it useful. So we have seen that database designers designs the schema for helping the programmers so that they can understand the database and make it useful. Types of schema. A database schema can be divided broadly into two categories, that is physical database schema and logical database schema. Physical database schema, this schema pertains to the actual storage of data and its form of storage like files, indices, etc. It defines how the data will be stored in a secondary storage. Here is where you have your data files, redo logs, control files, etc. Physical objects that reside on an operating system and are in raw state. These objects are used by logical structures to make our data make sense and readable. A physical model is what is actually implemented in your DBMS. Now we come to the logical database schema. Logical database schema is the schema which defines all the logical constraints that need to be applied on the data stored. It defines tables, views, and integrity constraints. A logical schema won't exist in your database. Why? Because it is logical. A logical schema is a design centric database structure built to meet your business requirements. It is a model that exists on a whiteboard or in a diagramming tool. It is like the architect's drawing of your database. Now, this is types of a schema we have seen. Now we will understand the type of a schema with the help of this diagram. We are seeing view 1, view 2 and view 3. This is view level, and then we have in the rectangle we have logical schema at the logical level and physical schema at the physical level. So this is actually a three-tier architecture diagram of DBMS which we have discussed in earlier lectures. So this is physical schema which we applied at the physical level, and logical schema which we describe at logical level. So this is what the types of schema we have seen from the structure point of view, that where how it is applied. So logical schema, we see the student ID, student name, project ID. So these are the logical view that we are seeing here at the logical level, and in the physical schema is the schema which is actually stored in our database as we have learned so far. So this was the diagram at three-tier architecture model. Now we will understand this concept with the help of graphics.
Hi, I'm Jared Hillen. The other day I had somebody ask me, what is a database schema? This is a great question. Hi, I'm Jared Hillen. The other day I had somebody ask me, what is a database schema? This is a great question and something that I think should get its own video title. I explained it in another video. It's something that needs its own attention. In essence, the schema represents any kind of structure that we're defining around data. This includes tables, views, fields, relationships, packages, procedures, indexes, functions, types, sequences, materialized views, queues, triggers, synonyms, database links, directories, XML schemas, and other elements. Without any of this stuff, it's easy to get lost in data. Imagine, for example, that I give you access to a folder housing a bunch of data from different sources, all jarbled together. Imagine trying to make heads or tails of such data. Now, with a lot of serious time and effort, you could eventually get to some kind of structure for understanding the data. That structure and its corresponding data relationships is what we call the schema of database. The application of that structure is something that each database vendor does differently. For instance, there are unstructured data stores which apply schema only when the data gets read. In other words, the data lives in its jarbled state, and we apply the structure to the query code. This is what's called schema on read. On the other hand, there are databases which force structure as a condition before data gets written. This is called schema on write. The method of how a schema gets designed can influence different behaviors in the database. For example, if a database schema is designed as a series of tables connected by primary keys, then it is likely something designed for reading and writing singular records, which is ideal for applications like Salesforce.com. However, if a schema has a central table connected to keys supplied by surrounding tables, then it's likely to be something designed to make read output highly efficient. This kind of schema is ideal for high-scale information delivery, which is called the star schema. When we're interacting with the schema of the data becomes an important topic. A good schema can mean the difference between a query lasting a few seconds to a query lasting many hours. And this isn't something that we can cheat our way around. The big data arrays prove that lesson to the entire market. Many organizations jump into Hadoop hoping for magic, but consuming millions of data with a conformed schema just made for really slow clicks. To get a sense of this concept further, you may want to take a look at the analogy I gave at the beginning of my video titled, What is SQL? When the Hadoop craze was at its peak and the emperor was still walking naked without anybody noticing, we had a new customer asking, why are we doing all this data modeling? Isn't data modeling an old concept? To which our solution architect said, I agree that data modeling is a long-tested concept, but it does work. Sort of like pi. Why do we still use pi? Isn't that an old method of calculating a circle? In other words, the concept of engineering an analytically focused schema will remain an important part of being able to feed information to a body of business users. Not only does it lower the processing time and cost, but it also reduces the code complexity of SQL queries. Incidentally, that customer is today another happy, referenceable electricity account. Now, generating a data warehouse schema is a process that requires quite a bit of iteration. Usually, systems which provide inputs into some documentation assets. Those assets ultimately lead to an early trial schema with a conceptual data model. This can act as a guide for determining development costs for the data warehousing project. Once a project is ready to say go on development, that early model will get iterated on multiple times. Often it will undergo this scrutiny of a rule plate to ask questions of the model which it can't answer. This beefs up the model's resilience, being a representation of the business's fundamental building blocks for analytics. Once this model is then physicalized to a database schema which the source data will be loaded and conformed to. Interesting specializes in this strategic.
So we have seen the database schema with the help of this graphic video. Now we'll come to the difference of physical and logical schema. The two can be different for a variety of reasons and in several ways. Your logical model should be properly normalized, but your physical model may have denormalization which you have added deliberately and for all the right reasons. Your physical model may have different naming conventions. Some people use plain English or the language of choice for their logical models and impose a more systemish naming convention in their physical model. Your logical model may have many to many relationships. Physical models implement M is to N using intersection tables. Your logical model may only use natural or business keys, whereas the physical models may also add surrogate keys. Now see, you can understand by this diagram, this is the logical model where this comes to physical and it is stored like this. So this is the difference between logical model and physical model, or you can say logical schema and physical schema. Here, former part shows the logical schema which is concerned with the data structure with exploring data structure offered to DBMS so that schema is very easy for the computer to understand. The latter part, that is the physical schema, is concerned with the way or the manner in which conceptual database gets represented in the computer as it is stored in the database. So physical schema is hidden behind the logical schema and thus can be modified without affecting the application programs. So this was the description of the diagram that we have seen so far. We can go once again to the previous diagram. This was the logical schema and this was the physical schema. So about this only I am just explaining this. The latter part, which is the physical schema, is concerned with the way or the manner in which conceptual database gets represented in the computer as it is stored in the database. Physical schema is hidden behind the logical schema. This is what you have to understand. The physical schema is hidden behind the logical schema and thus can be modified without affecting the application programs. We have not to affect the application programs and this can be modified. Why? Because it is hidden behind the logical schema. So it does not make any change over there. So now we come to the conclusion that you should have a logical model because it lets you think about your database design without having to get bogged down in physical constraints. You need to have the physical model because that will be where your data eventually lives. A sub-schema is a subset. Now we will understand what is sub-schema. Now we will see what is sub-schema. A sub-schema is a subset of the schema and inherits the same property that a schema has. The plan or the scheme for a view is often called sub-schema. Sub-schema refers to an application programmer's or user's view of the data, item types and record types, which he or she uses. It gives the user a window through which he or she can only view that part of the database which is of interest to him. Therefore, different application programs can have different view of data. Subschema can be modified as the subset or sublevel of a schema that has the same properties as the schema. In simple words, it is just an effective plan or the schema for the view. Well, it is interesting to note that it provides the user a window through which the user can view only that part of the database which is of matter of interest to him. It defines subset of areas, sets, records, data, names defined in the database that is of interest to him. Thus, a portion of database can be seen by application programs and different application programs has different view of data. Now we will come to another topic that is database instance. It is important that we distinguish these two terms individually. Database schema is the skeleton of database. It is designed when the database doesn't exist at all. Once the database is operational, it is very difficult to make any changes to it. A database schema does not contain any data or information. Means when we design the database schema, it never exists at all previously. Once the database is operational, it is difficult to make changes to it, and database schema does not contain any data or information because we have just created it. A database instance is a state of operational database with data at any given time. So this is what the clear distinction between database instance and database schema is, that a database schema does not contain any data or information, whereas database instance is a state of operational database with data at any given time. So it is a major distinction between these two, that a database instance have the data at any given time, whereas the database schema does not contain any data or information. So it contains, now database instance contains a snapshot of the database. Database instances tend to change with time. A DBMS ensures that its every instance, or you can say state, is in a valid state by diligently following all the validations, constraints and conditions that the database designers have imposed. Now, we will further see and understand the entire concept of database schema, sub-schema and instance with the help of another video.
Today we will be learning schemas, instances, and database state. So let's get started. The first question is, what is database schema? What is the definition of database schema? So the definition goes like this.